In job shop scheduling, you're always given 2 bits of information about every job, every order, or everything that needs to be done. You're always told something about how long is it going to take, or its duration, and then when is it due, or what is its due date, or what is its deadline. All other calculations and analysis, you're basically manipulating those 2 pieces of information. This particular question is a classic example of that. Job alpha, something to be done, requires 2 weeks of work. That's what I mean by like duration. How long it will take us to do it, and is due in 4 weeks, due date or deadline. Well, oh, wait a minute. Now, what's the actual question here? What is the critical ratio for this job? Okay, so a calculation based on this information. Critical ratio. Now, there's an important concept to remember. The critical ratio for a job is the time remaining divided by the work remaining. Critical ratio, generally explained by time remaining, and this would be for a job, for an order, for something to be done, divided by work remaining. Now, in this particular case, you're thinking, well, we're only given 1 sentence, and what's the time remaining and what's the work remaining? Well, if job alpha is the only thing we have to worry about, and it's the only thing in this problem, that means that, wait a minute, the time remaining is the due date. The time remaining is the due date because that's the time remaining until it's late, and the work remaining in critical ratio, if we haven't done anything right now, then there are 2 weeks worth of work. That's the duration. So that's what it winds up in this instance in translating to. Time remaining is essentially the due date, and work remaining is essentially the duration. Usually what the first iteration of these kind of calculations look like for any given calculation of critical analysis. Oh, well, there's our answer actually, is just 4 divided by 2, or 2. The critical ratio for job alpha is 2. Oh, now, speaking of those 2 pieces of information, and job alpha again, the next question, job alpha is due in 4 weeks. Okay, yeah, we knew that. If the flow time for this job, is 2 weeks, that is to say when we will finish it, what is the job's tardiness? Tardiness is easy to calculate if you have flow time, which we were given, because tardiness is the flow time with the due date subtracted from it. Oh, all right. So the flow time for this particular job is 2. We were told it's due in 4 weeks, so the due date is 4. Oh, wait a minute. There's something here I need to remember. Tardiness is essentially a comment on how late you're going to be finishing a job. So tardiness is flow time, which is when you're going to finish with the job, minus its due date, as long as that result is a positive number, because that's then a comment, if you think about it, on how late you're going to be after the deadline. If the result of that little arithmetic, flow time minus due date, is going to result in a negative number, that actually is indicating you're not tardy, you're early, tardiness is automatically 0. So tardiness is flow time minus due date if the result's going to be positive, but 0 otherwise, because that means that you're not going to be tardy. Well, 2 minus 4, right. If we're going to finish with this in 2 weeks and it's due in 4, we're not going to be tardy. It's going to be early. So the tardiness is actually, this is a reset, not a literal calculation. The tardiness is actually 0 for job alpha in this case. It's not going to be tardy. Now, speaking of job alpha, next question. Job alpha, well, wait a minute. Okay, job alpha's changed a little bit here. It is a different question. Job alpha requires 2 weeks worth of work, and oh wait a minute, there's another job in the mix here. Job beta requires 3 weeks worth of work. If job alpha is completed first and job beta is completed next, what is the flow time for beta? I just need to set up this schedule. Alpha is going to be completed first. Beta is going to be completed next. The question is about flow time. Oh, all right. Alpha is now, in this problem, 2 weeks worth of work. That means that if we start on it right now, this is just logic, we will be finished with it in 2 weeks, or the flow time is 2 weeks. Beta has to wait until alpha finishes because it's next. That means it will wait for 2 weeks, that 2, plus it's going to be 3 weeks worth of work. Its flow time is 5. That's actually what the question was asking, the flow time for beta. So the answer is that 5 for 5 weeks. We will be finished with the job called beta in 5 weeks. And that little calculation highlights in general how you calculate flow time. In a sequence, the flow time for a job equals the flow time of the job before it plus however long the particular job you're looking at is going to take.